In this video, we're going to be looking at drawing the graph of exponential functions without using a graphing calculator. So there's a couple of prerequisites to viewing this video. First of all, you have to know your transformation rules for graphs. And this isn't all of them, but this is the ones that we'll be using in this video. And the second thing is you do have to have a basic understanding of the basic exponential graph, what it looks like. So I'll be putting those on the screen. So let's start with this one here. So if I'm going to draw the graph of this without a graphing calculator, I'm going to need to start with the basic one. And the basic one here is going to be 3 to the x. Now the base here is 3. 3 is a number bigger than 1. And so it's going to have this shape. It's going to be, have the point 0, 1, so that's my y-intercept. It's an increasing function. As I move from left to right, I'm going uphill, so it's increasing. The horizontal asymptote is going to be the x-axis. The formula for the x-axis is y equal to 0. There's no vertical asymptote. The domain, we'll use the x-axis to measure how wide, and the domain is going to go from negative infinity to positive infinity. And the range, we'll use the y-axis to measure how tall. And we'll start at, but we won't include 0, and then we'll keep going up forever. And I think I have everything there. Now, how do I get from this formula to this formula? Well, the next thing I could do, the next change I could make is substitute, instead of the x, I'm going to put in x plus 2. Now, how has the graph changed here? I've replaced x with x plus 2. What happens if you replace x with x plus a number? Well, you shift it left. So the graph of g is going to be the graph of f shifted left 2 units. So that's not going to affect the domain. So the domain will still be negative infinity to positive infinity. It won't affect the range. We still have an increasing function. I still have the horizontal asymptote being the x-axis. There's no vertical asymptote. That hasn't changed. But I do need to find out what the y-intercept is. So there's still no x-intercept because my horizontal asymptote is the x-axis. But now what's the y-intercept? Well, if I plug in x equals 0 into that formula, then that's going to be 3 squared. And so my y-intercept is going to be at 9. Okay, and now how do I get that? Well, I take g and I subtract 1. And so for the graph of this one, what happens when you subtract 1 from the formula of a function? If you subtract 1 from the formula, that'll be shifting 1 unit down. So I'll take this and I'll shift it 1 unit down. Now I'll still have the same shape. It still will be increasing, but instead of having a x-axis as a horizontal asymptote, take the x-axis and shift it down 1, then this line will be my horizontal asymptote, and that's the line y equals negative 1. Okay. I still have a domain of negative infinity to positive infinity, and my range has changed now. Use the y-axis to measure how tall. Well, I'm going to start at but not include negative 1 and go up to infinity. There's no vertical asymptote. But now what about the y-intercept and the x-intercept. Well, the y-intercept, well, here it was 0, 9, and you shift it down 1, you're going to get 0, 8. Or you could just plug in x equals 0 into this equation. You'd have 3 squared minus 1, which is 8. What about the x-intercept? We do have an x-intercept this time. How do you find the x-intercept? You put your function, in this case h of x, equal to 0 and solve for x. So my formula for this is that. So let's add 1 to both sides. And if you have something raised to the 0th power, that will give you 1. So 3 to the 0th power is 1. What will make that 0 if x is negative 2? And so that is my x-intercept for that function. Let's go on, try and do as much as we can. How do I get the graph of that one? Well, I'm going to start with that function. Now, what does that look like? Well, my base here is a half. Since my base is a half, it's going to look like this. I still have 0, 1, but now it's a decreasing function. As I travel from left to right, I'm going downhill. There's no vertical asymptote, but the horizontal asymptote is the x-axis. There's no x-intercept. My y-intercept is 0, 1. The domain is negative infinity to positive infinity, and the range is 0 to infinity. Now, I want to try and build up to this formula. So the next thing I'm going to do is I'm going to replace x with negative x. What happens if you replace x with a negative x? You reflect it in the y-axis. So I'm going to take this graph and I'm going to reflect it in the y-axis. So if the y-axis is like a mirror and I flip it, I'm going to get this picture. Now, this will still have y-intercept 0, 1. It still has the same domain and range as we did before. The horizontal asymptote is the x-axis, and there's no x-intercept. But as we move from left to right, we're going uphill, so now this is an increasing function. And finally, I want to get the graph of this. Well, all I need to do to this formula is to add 1. And when you add 1 to the formula, that's shifting it 1 unit up. So I'm going to take the graph of this and shift it 1 unit up. And we can see my new y-intercept is going to be 0, 2. My new horizontal asymptote, instead of being the x-axis, is going to be shifting it up 1. So y equals 1. I still have the same domain, but now my range, well, I go from bottom to top on the y-axis. I start at, but I do not include 1. It's an increasing function still, and there is no x-intercept because we've got this horizontal asymptote of y equals 1, and there's no vertical asymptote. And finally, what about this guy? I start with f of x equal to 1/2 x, and again, since 1/2, the base is between 0 and 1, this is the picture we have. So its y-intercept is 0, 1. There is a horizontal asymptote, which is the x-axis. There's no x-intercept. There's no vertical asymptote. The domain is negative infinity to positive infinity. The range is 0 to 1. How can I create this? How about I negate the formula? If I negate the entire formula, well, since there's only one term there, I'm going to get that. Now, what happens when you change the formula by negating it? If you negate the entire formula, what it does to the graph is you get a reflection in the x-axis. So I'm going to take f and I'm going to reflect it in the x-axis to get the graph of this. And if the x-axis is a pond, then its reflection is of this is going to look like that. So my y-intercept is 0, -1. Here it was a decreasing function, but now it's an increasing function. As I move left to right, I'm going uphill. The domain is still the same, -infinity, +infinity. The range, well, I use the y-axis to go from bottom to top. There is no bottom. Now, this had a horizontal asymptote of the x-axis, and this will as well, because I'm just flipping it over the x-axis. So the range is going to go from -infinity up to, but not including 0. Okay. Horizontal asymptote is still going to be the x-axis, and there's no vertical asymptote. Now finally, what do I do to get this guy? I change this by adding 1. What happens if you add 1 to the equation? If you add 1 to the equation, we're going to shift 1 up. So I'm going to take this and shift it 1 unit up. So my new y-intercept here, so that's going to be at -1, so that'd be -1/2. If I take this and shift it 1 unit up, that's going to put it there. And my new horizontal asymptote is going to be y = 1. So I do have an x-intercept and a y-intercept. They're both at the origin. It's an increasing function. My domain is -infinity, +infinity. My range is -infinity all the way up to, but not including 1. There's no vertical asymptote. And I think I've answered all the questions for that. And the good thing about this is you can always check these, go into your graphing calculator and use it to check. And that ends the video.